Yeah, g'day. Happy Easter and welcome back to my surface grinder project. This is episode 4. The last episode I pulled it all apart and inspected everything, and I think I've finally got that spindle sorted. So in my last video, I had to strip down the spindle because the bearings were sounding terrible. And while I had it apart, I figured I might as well paint strip the spindle housing, so if my bearing regrease works, I won't have to pull it apart a second time. After scraping most of the paint off, I gave it a bit of a sandblasting to get the paint out of the worst bits that I couldn't get to. And now it's time just to put a bit of bog on it, cover up the worst of the defects. Right, that's now dried overnight, so let's block it back, ready for undercoating. I've got all of this rough sanded and masked, so now it's a quick rub down with some thinners, and then I can put some paint on it. Now, I was once asked how I set up my paint gun, starting with pressure off. I go out about 3 turns. Okay, that's a bit too much. And then just come out with the paint till I've got sort of coverage I'm looking for. Yeah, that looks about right. And then just use the fan depending on whether I want a wider or a narrower shot. Right, mask on. Well, the paint's dry, I can get on with other parts of this project. But I'm going to need the magnetic chuck installed. Already gave it a quick clean up before. When I was cleaning it, I noticed there were quite a few burrs on that bottom side. Hanging up there a little bit. Now obviously once I've got this machine all set up, I'll be regrinding this chuck to be parallel with the machine, but I won't do that until I'm really sure I've got a good feeling for the machine geometry. So it feels like it's got a few little dings in it. That might be beyond the scope of precision ground stones to do much with that. It really does need resurfacing on the grinder. Right, I'll just give it a light spray of wax just to stop any corrosion under the chuck. It's now the next day, and it's time to have a bit of a look over this and see what defects still need filling. There. Some of these defects are so minor they might just rub out. Right, I left that body filler to dry over dinner. Basically got two options for greasing these bearings. This is the grease which Maho recommends for the bevel gears of the vertical head on my milling machine, whereas NBU 15 is specifically a bearing grease. I have seen some references online that this can be used for surface grinder bearings, but this seems the more obvious choice. So how much grease do I actually need? If I look in the Schaeffler catalogue, you can see here for B72 series bearings, I've got a 0.5 at the back end and a 0.6 at the front end. So I need 1.5 milliliters of grease in the small bearing and just over 2 in the big one. So 1.44 grams. Not like I can get it that perfectly accurate, but let's see. Okay, so at the moment I've got just over 1.5, so don't put it all in the bearing. Since I was convinced that I shouldn't be using the ultrasonic cleaner to clean spindle bearings or any bearings, I've just soaked the grease out of these, and I'll use some air to give them a good clean out. Once you've cleaned all the grease out of a bearing like this, it's important not to rotate the races, but I'm not sure why. Someone will leave a comment on that, I'm sure. Now, given the way these bearings were sounding, they're probably toast. But I figured, since I already own them, their replacements cost about €360 for the two, and the grease probably only costs about 50 cents. What have I got to lose by greasing them, reassembling, and trying them out? So can I see anything under the macro that's interesting? No, not really. I just need to repeat that on the second one. I'm using these supposedly somewhat lint-free wipes, although I got feedback last time I used them that they're not really lint-free. Still, probably better than anything else I've got here in the shop. If the bearings still sound horrible, and if the if the bearings still sound horrible, and if the surface finish from the grind looks terrible, I need new bearings. This is the manual I used to pre-run in the grease into my bearings when I did my Mahu spindle. So let's just turn that down for this size bearings. Hey, while we're playing with the lathe, did you see the new video from Lake Factory Made, where Vasi covers the rebuild of his beautiful Weiler E30 CNC lathe? Link above or down in the description. Go and check it out. Give him some support. These cages don't leave a lot of space for the spudger. And now the small one. I did receive a request that I paint this in the original sort of blue-grey color, but that doesn't fit the corporate design, sorry. While inspecting the spindle shaft, I see there's a bit of a dent or something in here. Feels like it might have been dropped at some stage. Just get in there and dress that off. Both these bearings have got their eccentricity markings with these engraved V's. So I just have to make sure that both inner race V's are aligned and both outer race V's as well. I don't want the internals of the spindle to rust, so I'm just going to give them a light coating of waxy stuff. Can wipe it off all the bearing surfaces and stuff. I'll just start with a nice even coat. Probably doesn't hurt for the springs and fasteners to get a bit of this stuff too. It was kind of a crappy day here today and paint wasn't drying fast enough. So I just heated up my oven to about 70 degrees Celsius. Let it run for maybe half an hour or so to get some heat into the bricks. They still feel nice and warm and the paint's got dry. Going to need a good clean out. Still got some sandblasting grit down the middle of the bore, and that's a precision bore. Well, the paint job kind of came out kind of dog shit, but it still looks better than the gearbox paint on a 10-year-old Pratt & Whitney Canada turbofan. Right, I'll give this bearing a bit of a warm up. I preheated the oven to 70 degrees Celsius. There's enough heat in the bricks to maintain that temperature for a while. Oops, I got out of sync with my record button there because I don't have any footage showing the bearing sliding onto its seat really nicely. This front bearing space has got that row of springs installed in it. The springs are what give the preload between the two angular contact bearings. The rear bearing was a nice sliding fit into its housing. Then I heated it all up to 70 degrees again and it slid down onto its bearing seat with just finger pressure. That went great. Right, I just need to tighten this nut, and for that I've got two options. Either I'll pop out to my mate Franz's place, which is an hour drive, an hour of chatting and an hour back, and I'd love to go and see my mate Franz, but I really don't have 3 hours right now. So the other option is make one. Right, this tool's going to start where all good tools of course start, and that is the scrap bin. Oh, that looks promising. Oh wow, that looks perfect. First up, I'll just take the worst of the bends out of them. Since I need a pivot down the end, might as well just use the holes I've already got. Right, the other holes aren't really usable, so let's chop them off. Well, if that's 16, the hole's going in at 8. Right, tapping drill for M5, 4.2. Right, one of these bits is going to need a joggle in it, so I'll take this one. Right, now we get to the point in the YouTube video where that tool reappears looking fantastic. Surface ground, blued, radiused, polished. What else? Oh, engraved, of course, don't forget engraved. Yeah, no, I think you're on the wrong YouTube channel there, guys. I don't have a torque value for this nut, but since it's only clamping the aft bearing in a race onto a hard shoulder, I'll just get it up nice and snug. Well, that only took me about 20 minutes and it worked perfectly. Well, I fixed the anti-rotation pin. I made the missing screws. I already made the grinding wheel extraction tool. The anti-rotation feature of the back bearing carrier has to go opposite the mounting pins or locating pins of the bearing spacer. I'll give that one last wipe down before it installs. Now, what would you put on this? On the one hand, I'd be tempted to use that wax spray, but that might be pretty sticky and make it hard to install. Or I could use regular oil, but this bearing seats directly in the bore, and I'm pretty sure it's supposed to go and dry. Since this flange and the one on the back are kind of important, just make sure it's deburred. There's multiple little high spots that have taken off now, that's good. Now with the bearing preload being done with springs, this might not be as important as it is on some other machines, but it still never hurts to have things flat. Let's give this one the same treatment. Look at this, this has got 2 dowel pin holes, but if we look on the matching casting, it doesn't have those alignment dowel holes here at all. I suspect this machine, which was built in, I think, 1964, was originally a plain bearing machine, and the head was switched out to a roller bearing spindle at some later point. Before the spindle goes in, I'll just make sure this bore is really nice and clean. Being cast iron, these are never going to come out completely clean, but I think that's clean enough. Wait a minute, other way. Very easy to get something like this misaligned and jammed up. Certainly don't want to force it. There we go. Slots in nicely. Not sure if I can get enough light down there to make it visible, but I think I've got that little keyway aligned nicely now. But having 3 of these holes is actually quite helpful because I can use a drift in one hole to adjust the position of all 3. Oh, first scratch on a new paint job always hurts the most. It's like a scratch on a guitar. Unfortunately, I made these hex heads just a little tight. And unfortunately, I also don't have any Imperial Allen key bits, so I can't use my torque wrench on this. These 3 screws are really only to stop motion in the bearing spacer. Still think it's amazing that those threads in the casting didn't get damaged when the last person who was here cranked metric screws into this. But if you don't know what I'm talking about, take a look at the last video. I'll leave a link above. This little Allen key is so nice and small and springy that you can do a pretty reasonably accurate torque, I'm guessing, just matching the deflection from each one. There's no marking of how to clock this pulley onto here. The pulley itself's been balanced, so I'm just going to have to assume, I guess, that it can go in any rotation. Right, before I mount it, let's take a look at the run out. Okay, that really doesn't look great. For a precision grinding spindle, that should be 0. And it may be the corrosion on the end here, but I kind of doubt it. That would normally just give you more scatter. Anyway, I'll mount it, see what those bearings work like. It's really quite an interesting design with this casting here providing the vertical travel and it being supported on big kind of V rollerways in 4 positions. You can see 2 of them here. The metric number 8 socket fits. It's slightly tighter than whatever the banana socket was, but that doesn't matter. It means I can use my torque wrench. Now I thought I'd ordered a new belt, but seeing as it hasn't arrived, I did a check and I guess I did all the research on it, but didn't actually buy one. Oops. My belt tensioning again. Not exactly a fast method of adjustment. Alright, now I can put the oil cover back here, which covers up the lead screw, keeps the grit off it and keeps the oil on it. It just pushes down. Well, here I'll give it some oil. Well, with that motor connected, let's give it a first check of the spindle. Well, it sounds better. That's already an improvement. Right, well that's the work at the back finished, so let me just put the cover back on. Right, next up, way covers. This is how dust covers get really destroyed. Big build-up of dust. Then someone paints over it, turning it into a solid mass, and then the way cover's got nowhere to go but bends. Right, now the big final cover's got a bit of a dent in it here, so give it a panel beating. Some of this built up sanding dust is held in place with big blobs of paint, so that can come off. These are obviously going to need a repaint at some stage. Now you might be wondering why I'm putting these covers back on in this condition. I have no expectations that this is the final maintenance I'll do on this machine, but at this stage I would like to get it running and just see what it grinds like and see what other issues it might have. Well, I'm starting to actually get a bit excited about trying this thing out. Not much longer now. So this was the wheel that was fitted when I got it. I know nothing of its provenance. Let's put one of these wheels on. This is one of the ones which I was given by my mate Luke down in Malta. The blotters I got from Tim in California. Thanks a lot, guys. So it goes, I guess it goes blotter, wheel, blotter, then the shim. Looks like I might need to grind away a bit of these edges. Lucky I put no effort into making them look nice. Now some of you might be wondering why I'm not using this pen spanner, but it's for an American Boyer Schutz angle grinder, and they must have different pin spacing. Need to cut just a bit more off there. Actually, no, to run in the bearings, I'll use this one because at least there's some chance that it might have been balanced in the past. Right, now before I can try grinding anything, I have to run in the grease in those bearings. I'm going to use the method from the Schaeffler catalogue, and that's 20 seconds on, 2 minutes off, for about 5 cycles to start with. God, those bearings are sounding a lot better. But even though they sound okay, they may still be dead. We won't see until we actually start grinding. Unfortunately, the run-in method that's offered in the bearing catalogue starts with only half speed, but this is a single speed machine. I don't have any easy way to run in the bearing slower, so I'll just use shorter initial periods of maybe 10 seconds. Right, I've now been through 10 reps each of 10 seconds, 20 and 30 seconds on, each with 2-minute breaks in between. And now it's time to switch to minute on, minute off. And I'm using my magnetic chuck to remember which iteration I'm in because I need to do this 10 times. And if you ever want to see time racing by, set up something where you have to do an action every 1 minute for 20 minutes. Okay, this is the last one. Do you hear that ticking sound? Oh, it's gone now. Sounds like unhappy bearings. I'll just dress this wheel because it looks pretty out of round and do a test grind because I want to. Just hold a diamond in my little homemade chuck here. Takes 30 seconds for this wheel to run down. Okay, that's not dressed yet. That looks better. This is some tool steel from Weiler. Seems pretty hard. So let's give that a go. Okay, just move these stops in a bit. Whoops, that was a bit too heavy a cut for this wheel, so I backed off the feed a little. You set the crossover step with this little Scotch yoke here. You just have to be careful that you tighten it with a spanner, because if you only do it by finger tight, it tends to loosen and increase the stroke. The crossfeed direction changes with this lever in the hand wheel should really stop the feed first. Crossfeed start stop, and I believe speed is this little lever on top. Now, I'm sure that's not the right wheel, it's not balanced. The bearings are probably shagged, but man, not bad. Hey, check this out. See, it makes a nice, smooth, shiny surface. Yeah, so what do you think of it?
It's actually kind of cool. A few sparks.
Yeah, it needs more sparks, huh? Maybe a better grinding wheel will give me more sparks.
I like them.
Well, I'm not sure if they're going to stay done, but that's the spindle bearings greased. This is a pretty cool tool. Now, obviously, I'm going to have to do a bunch of tests to find out how parallel it's grinding at this stage. But for a very first attempt, I'm pretty darn happy with that. Right, well, there we have it. At this stage, I'm not going to race in and replace those bearings because the surface finish I'm getting is looking good enough to start with. Got heaps to learn on how to use this thing properly, but I'm super happy to have it running. From here on in, it's all just improving it. Thanks a lot for watching, and happy Easter.